Only in 3, 2.
1. Hey everybody! We're talking today about solving quadratic equations by completing the square when a is not equal to 1. Specifically, the leading coefficient of the equation, where's my cursor? Ax squared plus bx plus c equals 0. So if a is not equal to 1, completing the square is a little bit trickier because I am actually not allowed to have a be a non-1 value for that to work out. So I've got a couple different solutions that'll work. One of them is usually easier than the other, although the other skill is necessary later on in your life, specifically in Math 4. So let's take a look at this first example. So you can see that, what is the value of a in this problem? 2. All right, so it's not equal to 1. Let's go about this problem the same old way so far. I'll move the old C term to the other side. The old seafaring captain to the other side. 2x squared minus 6x equals -5. And now the issue is, if I wanted to complete this square, all right, I don't know how. Well, and also the problem is that a is not a perfect square, and I would kind of need it to be.
Well, then you'd have to divide 5 by 2, too.
And you would. So that's one solution. I'm going to show you that. Well, yeah, let's just do it that way. Divide by 2, divide by 2, divide by 2. This is the easy way, but I'm going to show you both. X squared minus 3x blank equals -5 halves blank. All right. And now I can complete my square because the leading coefficient is 1. So I'll do the classic -3 divided by 2 all squared. That doesn't reduce, but I can just square top and bottom, and it's going to be positive, by the way, because of the parentheses. So that's 9/4. So I'll add 9/4. Fourths is not as bad as sixths. So add 9/4 to both sides, in fact. So on the right-hand side, I need a common denominator. What's that common denominator going to be?
4.
4. So what should I multiply this one by? 2 over 2, right? And let's see. I can fast factor the left-hand side to be what all squared?
X.
Yep, whatever I had right before I squared it. Or the square root of the C term. Or half of your B. It's all the same difference. As long as the square root of the C term one, you just have to make sure you're aware of this sign. And over here, this would be -10/4. Good, buddy? So, -10/4 plus 9/4 is -1/4. And let's see, next step, what do I do? Root both sides.
Wait, how did it turn into 1?
-10 plus 9 was -1. And plus or minus, don't forget it. It's all about technique. So the square and the square root will cancel out. I'll have x minus 3 halves equals plus or minus. What is the square root of -1?
1.
And the square root of 4 is 2. Which, by the way, pretty much 100% of the time, these denominators will always end up being perfect squares, which is really nice. It's a nice deal. Because then you'd have to mix in rationalizing your denominator in the middle of these problems, and that would not be fun. Add 3 halves to both sides, and I'll get x equals 3 halves plus or minus I square over the, sorry, no square root in there, I over 2. I over 2. So that's the first technique, probably the easiest, is just plain old vanilla divide both sides by a, no matter how many ugly fractions it makes, and that'll work out nice. Let me show you the same problem real quick. 2x squared minus 6x equals -5. Parallel universe. let's see, here we are. 2x squared minus 6x, was it? Equals negative 5. Now the other way you could have done this is by factoring the a out of the first two terms. Not the GCF, just the 2. Because the GCF would have included an x that I would have swiped from both of those. Yes, I swoped it. So this would have 2 parentheses, x squared minus 3x blank equals negative 5 blank. Now, let's see what happens. How do I find my new C term? Hey, that looks familiar. 9/4. I'm going to add 9/4 here. But behold, careful. Adding 9/4 in my small village of parentheses had some greater effect on the world, somewhat like the butterfly effect, where adding 9/4 here was really adding 18/4 or 9/2. So I have to do what over here? Add 18/4 or 9/2, or I'll just write this as 2 times 9/4, just to make sure it's explicit. That, right? Adding this in the world of parentheses was really having a greater effect on the overall world of the problem. So, what, half of what? Well, twice the 9/4 technically. 9/2 would be.
No, it's on the other side.
Oh, put half of it in here? Yeah. Well, then it wouldn't have given me a perfect square trinomial. Okay. But there will be some halving taking place in a moment, which we'll be able to do. Let's see. On the right-hand side, let's see. So this is 9/2. So my common denominator is going to be halves. So I'll multiply this by 2 over 2. And I'll get negative 10/2 plus 9/2. And if you're wondering where that halves comes from, the 4 and the 2 partially canceled, leaving me 2 left. And so what do I have when I combine these? Negative 1/2. Oh, I'll write that in blue. And what do you think I should do next? Oh, wait. We got to factor that. What's that factor become? X minus 3/2. And now what could I do? If I square rooted, yeah, the easier way is to divide by 2. So I do end up still dividing by 2 in the end. So this way is probably a little bit trickier, and dividing a half by 2 is a quarter. And then that is work from there that we've already done our work for. But when we are doing conic sections in Math 4, we actually will have to know this sort of technique where I can't just divide everything by something. And you'll have to know how to do this weird little complete the square trick and notice that you're having a greater overall effect in the world of the problem than just what you did on the inside of parentheses. So that's why I show you the other technique. So let's look at one more problem. Yeah, that's right, just 2 problems today. No es más mal, es el más bien del mundo. What if I've got negative 4x squared minus 3x plus 1 equals 0? So let's move the old C term to the other side. And I get equals negative 1. And we'll do this the easy way this time. We'll just divide everybody by negative 4. Let's see, there's my mouse. Bam. I've been having mice come into my house lately, getting on my stove, eating my crumbs.
That is disgusting.
Yeah, it is. But he does a fair trade where he leaves some of his own crumbs in return. They're just digested.
Stop!
This is on your video right now.
That's all right. So I'm trying to figure out if I should like clean my stove and then like tinfoil all of it, all the
Why
holes.
is this relevant?
I don't know, because I was not able to
It's
find my
not,
mouse.
Natalie, that's the point. It's just
So,
not.
all right, so now I'm gonna try to complete this square,
I don't like it.
and yeah, it's a little bit gross, but it can be done. What's the technique? What should we do even though we don't want to do it? How do I find this?
3/4 divided by
3/4 divide by 2 and square it is how we'll find our new C term. Dividing a fraction by 2 is the same as doubling the denominator. So that's going to be 3/8 squared. So that's 9/64.
Whoa.
If you guys find that you need some fraction help, check out my old friend Khan Academy. He's got
Can
a
you just stop?
good-
I have the worst idea. It just,
I
no.
don't even.
does not do this problem.
I don't get the bottom part.
This
Why-
from here to here.
Why is 3/4 squared just randomly turn into 9?
Wait, 3/8 squared?
Yeah, I don't get how that happens.
Well, you'd square the top and the bottom.
Okay.
Wait, no, I don't understand.
From here to here?
Yeah.
Okay. 3/4 divided by 2, you double the denominator. So dividing by 2 is the same as multiplying by a half, is what that's doing.
All you did.
So 3 times 1 was 3, 4 times 2 is 8. Yep. And then 3/8 squared, you just square top and bottom.
So in that case, the second method wouldn't be possible. The other way of doing.
The other way of doing it still would have ended up with some fractional work.
It would have been possible to do it.
Yep. Yeah, it would have. I would have factored out. Actually, we'll analyze that once we're done the problem. I won't do the whole method though. So let's see. To add these, what do I need to do? Okay, which is 64.
Well, you can do.
So I have to multiply by 16 sixteenths, and I would get 16 64ths plus 9 64ths. This is all just scratch work. Equals 25 64ths. And can you believe I just made up this problem the other day, or just not the other day, today, and it happened to have such a perfect square. Isn't this just a perfect problem? What is this factor to become? Plus 3/8. Right, the thing that I had right before I squared it.
You're making me real mad real fast, boy.
Okay. Root, plus or minus. Don't forget it.
We won't, Dad. Dang it.
Yeah. Someday I'm going to make a bumper sticker that just has plus or minus on it, and it'll say never forget. And then no one ever will. X plus 3/8 equals plus or minus. Square root of 25 is 5. Square root of 64 is 8. Oh, guys, look how awesome this is. They already have common denominators for us. So I'll get x equals, let's see, negative 3 plus 5 is 2. 2/8. And negative 3 minus 5 is negative 8. And then I get my two answers of a quarter
Of course.
and negative 1. Now the fact that my answers are rational numbers, what I mean by that is they are fractions or can be written as fractions without square roots in them, suggests that the problem is actually originally factorable. Kind of cool. Let's talk real quick about what would we have done here if I'd tried it the other way. All right, and I'm not going to do the whole thing out. I just want to.
I would take it out -1.
Well, you actually don't have a choice. Sadly, we have to always take out A, no matter what.
So you take out all of that?
You have to take out A. So it's not a GCF. It's just taking out A. So So check this out. This is actually kind of tricky. Negative 4 times what is negative 4x squared? Seymour, friends, guys? And negative 4, here's the tricky part, times what would give me negative 3x?
Every
A
four,
fraction.
every 3/4.
Positive 3/4 x?
Yeah.
And he's correct, right? Because the 4 times that, the 4's would cancel out, and the minus sign would be introduced. So I just want to point out that that is possible, and that'd be all cool stuff. Let's see, and then I would have added, what was it, 9/64 in here? If I added 9/64, what would I have had to add over here? Or,
Well, no, you have to multiply by 4. 964 times 4.
actually even worse, the negative 4. So that means instead of adding, look at this. I thought I did a positive thing in this little village, and somehow some like
Turns negative.
warmongers came and stole all the food that I donated, and now are like forcing people to be slaves, and they're selling it for like really high prices. And I thought I was doing a good thing, and it ended up having this really negative effect in the long run, and I regret it. So I'm actually, instead of adding over here, I'm subtracting 9, 64, and 4 reduce 16. So that's kind of really weird. The rest of this problem ends up kind of being the same as the portion above it. So I just wanted to point out this peculiar,
That's gross.
yeah, that's
It
not.
has liar in it.
Indeed. So, so yeah, it's kind of tricky. Also, yeah, if you're doing it that technique, you always have to factor out the whole A and nothing but the A. Bye-bye.